looking for? I hope so, because if you're not, then you've come to the wrong place. Because this is the place where we're doing our lockdown maths every day, except for the days when I don't do them. Then, so most days, probably 4 days a week, we're going to be doing some lockdown maths. Today is all about volume. No, sorry. Today is all about volume and surface area. I misread my auto cue. Not that I've got an auto cue. I wish I did have an auto cue. Maybe I could just get the dog to hold some cards just above the screen so I can read what the dog's saying. But it would probably say things like get Star a biscuit, because she changed the cards. She's really, really good at writing. Anyway, I got a bit mad. So what we're going to do today, we're going to learn about finding the volume. We're going to make sure we know what prisms are. I know that Alex has been saying that he's feeling imprismed. But we're going to make sure we know what prisms are. We're going to find volume and surface area. And that's what we're going to be doing today. So, without further ado, volume and surface area. It needs 3D shapes, and I have made myself here my Ultra Pro deck box, and with it we can talk about volume and surface area, because we first of all need to know why we're learning about it. Now, we're going to be learning about volume, which is the amount of space this shape takes up in the world. If it was solid, it's not. It's got cards in it at the moment. But if it was solid, the amount of space it takes up is its volume. If it's empty, it's the amount of stuff you can put inside. So this glass, the volume of this glass, is the amount of water I can store inside it. Now, surface area is the amount of space around the outside. If you imagine you're wrapping a present, it's the exact amount of paper you would need, the minimum amount of paper, I guess, because there's going to be some wastage. When I was trying to wrap this, you always get bits around the edge. There's the minimum amount of paper you'd need to be able to wrap every part of the outside of a shape. So what do I mean by prism? It's not a place where you're trapped. Sorry, Alex. It is a space. The prism is any shape which has got a cross section. So you can see here this square goes all the way through the shape. There's lots of prisms. Smarties tubes, for example, are cylinders, and they have a circle that goes all the way through the shape. You can even have some quite crazy ones. You can have ones which are... I've lost the ability to speak. Let's relearn to speak, I guess. You can also have ones which are like trapeziums that go all the way through, or you can have a cross that goes all the way through, or a crazy weird shape, and I'll do one of those on the smart board at some point this session. So let's move over to my PowerPoint, and we're going to get started today. We've talked briefly about what volume is and what surface area is, so we're going to have to learn how to do it. And before we can do that, I have a challenge for you. No, you can't do that, Mr. Harris. We've talked about this. You have to actually be there. We're there. One thing, I've got some stuff from the Harry Potter thing. I want to see pictures of your work. Please, please, please send me stuff through. Please, the more stuff I receive, the more I can put. I would like to do a gallery each Monday of all your work, the Harry Potter stuff. I saw some brilliant stuff. Some more stuff you do, take photos, put it on the Facebook group, send emails to me. The more stuff I have, the more stuff I'll share. I'd like to create a community of Harris Hawks who are all doing maths throughout the summer. I'm hoping we're going to add to the number of Hawks joining us each day. So at the moment, we've got 35 of us live, but I know by the end of today, it'll probably be 150 people who have joined this thing. So send me your work. Even if you don't do this live, send me the work, because I'd love to see you featuring in the videos themselves. So, unfortunately, the Tiger's got a day off today. He's been working from home. He's started to get some symptoms, so he's going to stay and work from home. But he's sent Panther along just to make sure you're doing these questions. What I'd like you to do is work out where I've got those purple areas from. So I've written the answers down. How have I got those answers? Where have I got those numbers from? Why is the area the purple numbers? So it's different from normal. Normally I wouldn't tell you the answers. Feel free to pause the video now, or if you're watching it live, I'm going to go through each one. So a reminder, If we were asked to find the area, rectangles, the area is just base times height. So we've got 6 times 3, because the base is also the top bit. They're parallel, so it's 6 as well. 6 times 3 is 18, nice and straightforward. The bottom left, we have a composite shape. Composite shapes are made up of more than one individual shape. I've got here, the right-hand rectangle will be 2 times 9 is 18. And the left-hand one, we need to first of all work out its height. So because it's 6 down the side, that means it must be 3. So 3 times 5 is 15, and 15 add on to 18 is 33. Pause. We've then got the triangle, and I've deliberately put in a number you don't need, just to throw people, because it's the base times the height, not the 5 going up the side. The 5 does not get considered. Don't be confused into thinking, I'm just going to times all the numbers together. It's not what we do. We get the 5 from the base, we multiply it by the 4 from the height, and that's 20, but we have to remember to halve it. So that's why it's 10. Base times height and halve it for triangles. So, where does that leave us? We are now about to embark on a journey where I'm going to make sure you understand how to find the volume of these shapes. After we've done that, we're going to look at the surface areas, but we're going to do the volume first. To do so, I need to jump into the front seat of my whiteboard screen. And we have, first of all, a cuboid. Now, the way I draw cuboids, I go along to draw a rectangle, diagonal, 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 up and across. If that's useful to you when you're drawing out cuboids yourself, that's how I do it. Now, you can just know that for a cuboid, it's base times height times depth. But I think it's more useful to know why. And it's because of the rule of prisms. The rule of prisms is it's the area of the face that stays the same. We call that the cross section. And you might see some places refer to the CSA, which is the cross section area, times by the length. So if we can see on here, here's the cross section, which is depth times height, which is why there's your height times the depth times by the length, which is the base. So you can see this is using the same as the prism thing, but it just so happens to be times them all together for a cuboid. But where it really comes into its own is if I was doing a triangle prism. Here's my triangle. Hopefully I'm not in front of it. I'll check over there in a second. Hopefully when it appears, I just talk random waffle until I can check in my thick screen. We've got a base, and remember, we don't want the slant, we want the height, and we want the depth. And the rule of prisms says we need to take the area that goes all the way through. This triangle is what goes through this prism. Triangle, 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 triangle. So this is what gets multiplied by the depth. Now remember, this is going to be, the area is going to be base times height and half. So the volume must be base times height, halve it, times the depth, times the length here. You can call it length, you can call it depth, as long as you understand what they both mean. Depth is, I use depth because it's like how far into the screen I'm going. So what we've got here is for cuboids, which are the main things we're going to work on. We're going to do an example, but I'm going to teach it and then do an example, rather than just do an example and then do another bit and then do another example. It's just, this is how I'm going to go about it. We can even, and I expect some year 8s and 9s to be able to do this, if I've got a cylinder and it's got a length and it's got a radius, I wouldn't expect year 5s to do this. Don't worry if this is confusing, that's absolutely fine. But you can find the area of the circle, which is called pi r squared, and that's pi r squared times length, because once again it's the area of the shape that goes through it times by the length or depth, whatever we choose to call it. So we're probably ready to do some examples. I think so. Got to be careful how I do this. Ta-da! New screen. So here's my first example. Draw my cuboid. And we first want to find out what the volume is. That's 12 centimetres, that's 3 centimetres, and that's 2 centimetres. Not the neatest of centimetres, but we can see what we're doing. Remember, two ways to do this. They both work. You could do volume equals 12 times 3 times 2. It's helpful to you in the long run to understand why it's actually 3 times 2 is the area, and then volume is 3 times 2 is that answer. I'm going to change that to a 6 just so we can all see what I'm talking about. And we're going to write that as 6 times by the length, which is 12. Notice the same answers. Volume is in cubed, and that's 72 centimetres cubed as well. Cubed because there's 3 dimensions to it: a length, a height, and a depth into the page. The reason I've done it this way is to help you if you go on to the extension tasks and the harder bits, because they are going to be always needing you to find the area and then times by the length. But for the cuboids, you can just times all together, especially in year 5. Year 5, it's absolutely fine just to do times all the numbers together, and it doesn't matter what order you do them either. You could do 2 times 3 times 12, or 12 times 2 times 3, or 12 times 3 times 2. They'll work in any order, and that's where we've got that volume. I'm going to pause so you can absorb it, because I'm sure if there's some year 5s and 6s watching this, they'll be like, huh? Okay. I will look out for questions while we're going. And the reason Thial is 72 centimetres cubed, not squared, is because we're talking about a volume here. And if this would be centimetres squared, but we're now talking about a volume, which means we need 2 centimetres cubed. But I promised that this is going to be about surface area as well. So what better way to learn about the surface area than to have this example that we're working with? And what we have to do is imagine this is a box, and we open the box up. And we create, it's kind of in reverse, we create the net. I want you to imagine I've just opened all of this box up. And so I've still got, these are all 12. But these ones is 2 and 3 and 3 and 2 and 3 and 3 and 2 and 2 and 2 and 3 and 3 and 3 and 3 and 2. All I've done is opened up this 3D shape into a net. And this will work for any of these shapes we're doing. You open up the net, then go to my nice pink that I've been using for all of these. To find the surface area, it is the area on each of these surfaces. There's one, there's another one, there's another, and there'll be a back one, a bottom one, and a right hand one as well, which is why there'll be 6 faces, because cuboids have 6 faces. And let's check. We've got 1, 2, 3, 4, 5, 6 faces, so we can work out 3 times 12. Don't times all the numbers together, just base times height is 36. This one is 2 times 12 is 24. And because this one's 2 times 6, because it's a cuboid, it will actually repeat. 36 and another 24 and another 6. Because there's pairs. We've got a front and a back, a top and a bottom, and a left and a right. That's why there's pairs of numbers. So then to find the total, we then have to do a calculation of 6 plus 6 plus 24 plus 24 plus 36 plus 36. And then we go 32. I'm sure you all make that noise when you're working things out, right? 3 and 6 and 9, 11, 13, 132. Now, this is where, Thial, this is centimetres squared. Because this is an area. It's called surface area. So if it's surface area, we do need centimetres squared. Okay? Sharanya, if you've got a question, please don't say I've got no clue. Please ask me a question if you're stuck. You have to tell me where I lost you so I know where to pick up and where to review. If you just say I have no clue, I will not know what bit you'd like me to go over again. So it's really important when you ask me questions. I say this to all the students in my class. If there's any of those here, they'll tell you that in my class I always say to students, You can't just say I'm stuck or I don't get it or I don't understand. You have to say a question, a why, a how, a what. For example, you might say, what did you do to get the 72? Why have you drawn this shape? Anything that helps you to know, helps me to know what I need to explain better. But actually, should we do another question? Because that might help with the people who are a little bit confused. Here we go. This time, I'm going to do a triangular prism. Slightly harder, because if you're really stuck, you can rewind the cuboid and you can go back and watch the cuboid again. So that's fine. But this time, notice I will need these numbers. And I've actually got a equilateral triangle here. And that one would be, I'm going to have to use a calculator for this because I want to get it right. 2.5 squared equals, and it's 25 minus answer equals, and then square root that answer equals 4.33. You will one day learn how I just did that, but for now, it's enough to know that's 4.3. It wasn't recurring. I don't know why I've put a dot. 4.3 is fine. Oh, I've rubbed out the wrong thing, you silly man. This is how you know it's live. And then we're going to find the length is 8. Now, sometimes you might need a calculator. We've got the volume. Remember, is base times height is going to be the area first. Let's always stick to the same method. Find the area of the triangle first. So the area was 5 times 4.3, all divided by 2, is 10.8. So the volume is going to be 8 times 10.8, because you take that area and times it by the length. So it's going to be 86.6. And notice how you're allowed to use a calculator for ones where there's decimals involved. You don't need a calculator when there's not decimals involved, so that's cubed. But we also want the surface area. If we imagine unwrapping this, remember it was all about wrapping, that's why I made the silly pun in the title of the whole video. We have got, these are all 8, there's only 3 because there's a triangle, and then this is 5 by 5. But we fortunately have already worked out that this was 10.8. That's one of the things we get to use from the previous answer. Look, that bit there allows us to put 10.8 in the two triangles. Then we just have to add, well, that one's going to be 40. 8 times 5. 8 times 5. Oh, missed out 5. 8 times 5 again. 8 times 5 again. So we get 40 plus 40 plus 40 plus 10.8 plus 10.8 is 120, 130, 140, 141.6 centimetres squared. Okay. How did I get 10.8? Excellent question. I worked out, I used the 4.3 here. In a triangle, you always have to multiply the base times the height and divide by 2. Triangles are always base times height and divide by 2. Okay? So that is the surface area. I'm going to call it SA. So I've been doing English and maths because I've just done an essay. Never mind. Okay, let's go back to the studio. Hello! It's me again. Okay, you've been seeing me in this bottom corner, but I'm here. So where are we going to go from there? Well, you have a challenge. You have a volume and surface sheet that a very, very kind lady has helped me fix because I didn't do it properly. I would love it if you could attempt all the cuboids. If you're feeling brave, try the other shapes. The Trapezium Prism is hard. You may, especially year 8s and 9s, should be able to have a go at that. The Trapezium, to find a trapezium, it's the top at the bottom. Top at the bottom times the height and then divide by 2. And the way I teach people is the trapezium is half times top plus bottom times height finds the trapezium area right. Half times top plus bottom times height finds the trapezium area right. I then wanted pictures. You may have noticed I've mentioned pictures a lot. I'm not going to do this in every video I do, but I'm really trying to drive at the moment pictures and interaction with you, because I want to interact, because I'm sitting at home all day only interacting with my dog and my wonderful wife and soon a wonderful little baby. But I'd love to interact with you and see the schoolwork you're doing and all the maths work you're doing and the bright colourful things. And also just let me know any feedback, any questions you have, anything you want me to go through, anything you want me to explain. Winnie has asked me to go back. She says it's 86.4. I may have made a mistake. Where have I got 86? Where's 86.4? It's because 8 times 10.8 is... I am using... Now, this is something that you need to... this is very difficult to realise. Your answer would be correct as well, Winnie. But what's going on here... Let me just show you. When I did... This is something that you do when you're more advanced at mathematics. This answer... I didn't round in the calculator. So that one there is not rounded. I've rounded it when I wrote it on the screen, but I left the whole answer in the calculator. So when I times my whole answer, that's why I got 0.6, not 0.4. So although if you did it with 10.8, that's absolutely fine. Your 86.4 is also right. But it means I don't lose any accuracy. If I keep the answer in the calculator and I use something called the ANS button, I'm really pleased you brought this up. That's an excellent observation. If you use the ANS button, it means that you don't lose any accuracy from rounding too early, because we should never round till the end. So it's a very good observation to make. Well done for spotting that. So have a go at them all, show me stuff, and share this around. At the moment, I can see 34 people here and only 7 people liking it. That means, clearly, I'm not doing a good enough video, because we need to have better videos if more people like it. Or, maybe you did like it, in which case, consider liking the video. Please consider subscribing if you haven't already. Please let me know. Please make sure you come back the next day, because if nothing else, we have to speak to Alex, because he's an imprisoned boy, or the prison boy. I think we should call him the prison boy. And hopefully, that has been helpful to you all. I have been Mr. Harris. You have been my wonderful Harris Hawks. I'd love to see the work you've been doing. I'd love to find out what you're up to. Let me know, and remember, if there's a topic you want to cover, I will only know about it if you tell me. You are all fantastic. I will hope one day I will be too. Goodbye.